I'm Rajat. I work as a platform engineer at Fermion.
I'm Karthik and I work as a software engineer at Fermion.
So today we are going to talk about serverless and WebAssembly and how they gel up with each other. To start with, what is WASM, right? So WASM is, the boring answer is that it is just another bytecode format. It was created by browser vendors to basically run the web apps in browser at native performance speeds. And as you can imagine, running apps in web browser, they need to be securely sandboxed so that they don't get access to your computer. And they need to be cross-platform. You don't want apps to be building for different platforms, building different apps. You want them to have fast execution and startup times. And ideally, it can ideally should be able to run multiple languages, be able to develop in multiple languages. And these were essentially the strengths that WebAssembly brought to the table. It runs in a security sandbox where the capabilities are provided based on the host system restrictions, like the guest code does not get access to anything unless host provides it. And you can compile any language to WebAssembly on a cross-platform basis. And once you compile it to a WASM file, you can pretty much run it on any operating system. It has fast startup and execution, like really fast startup and execution times. And we can compile a whole bunch of languages into WebAssembly today. Like a lot of languages are coming up with their support for compiling into the WebAssembly. What turns out to be the technology that was built for the browser, it turns out that that technology and those are the use cases for a compute platform as well. We want the thing running on our compute platform to be fast, secure, and at the same time be able to compile multiple languages into that into the WebAssembly and be able to run on any platform. So this is where server-side WebAssembly came into picture. And one of the reason why it is shining here is that a lot of developers, they want to move to serverless platforms because cost optimization. But one of the biggest pain point is the cold startup time. So for example, with Lambda, it takes about 250 milliseconds of the cold start time, and then your code execution starts. While with WebAssembly, the cold startup times are like really, really low, and then your code execution starts almost immediately at native speeds. And this is where WebAssembly on the server side brought shine to the WebAssembly stuff here. So WASI, what is WASI? So WASI is the WebAssembly system interface, which provides basically access to conceptual operating system via the spec. And it basically have the same security model that we have for apps in the browser. And guest code is only able to perform the actions that host is providing access to via the capabilities. So for example, if you want to make outbound HTTP request, unless your host approves it, you can't make that request from your guest code. So you have to explicitly safe list the host that your guest code can connect to, and only then you will be able to make the request. Some of the WASI runtimes, so WASI is a spec, and then there are runtimes which are implementing that spec. So for example, WASM time is one of that. WASM Edge is another one. So they basically implement that spec and provide the runtimes for WASI. So this is where Spin, our open source developer tool, which is also a runtime for WebAssembly, comes into picture. It basically provides a very good developer experience of starting a new function, implement it and run it in WebAssembly using WebAssembly. So starting a new function is as good as you just run a spin new command. It comes with a whole bunch of templates which are written in different languages. There is Go, Rust, Zig, and then you can just do a spin build and run your app, and your app is up and running with very, very minimal cold start time, like 1 millisecond or something like that. So writing the serverless functions, generally people think about it is good for stateless kind of applications. But once you start getting into some more serious projects, like where you want to persist the data for the user, that's where serverless with some sort of storage comes into picture, and you need data persistence to be able to do stuff. So this is where Spin also provides inbuilt support for key value pair, which is backed by a SQLite implementation. So when you basically do a spin up, we bring up a KV implementation for you automatically, and then you are able to store data and retrieve data from that KV store again in milliseconds time frame, which is really fast. Spin also has support for no-ops SQLite DB. And why I say no-ops SQLite DB is because when you do a spin up without having to do anything, you have access to SQLite DB automatically, and you can just start using it inside your code. And so the operational perspective, the things like as a developer, when you start working on stuff on your local machine, it's all fine. You can start a container that is running, let's say Postgres for you or some other database. But once you have to start deploying stuff for production or to somewhere else, that is where you have to put a lot of configurations, the username, password, managing that database itself, and all those stuff comes into picture. But with Spin, you basically can replace all those things on the fly. I'll show you in a minute about that. So this is where the NOPS concepts comes into picture, that you don't have to deal with a lot of stuff. You can just do a spin up, or in case if you want to deploy to a centralized server, you can do a spin deploy. And it comes with implementation that providers provide. In this case, Firmware Cloud also provides us SQLite implementation, for which you don't have to store any credentials or anything anywhere. You just access it from your code, and it just works without any credentials that you need to provide explicitly. So this is a very simple example of how KV store works. In this one, you just say kv.open default, and it will open, like when you're running spin up, it will open the implementation which is running on your local system. And you can just check, do operations like what you want to do. You want to check if this something exists in database or not. If not, do something about it. Like this is a counter example that we are going to do a demo of very soon. And if you want to replace this, you don't want to use this, and you want to replace it with, let's say, for example, Redis, what you can do is you can use the concept of runtime config. So you can just create a runtime config where you say the default KV store, instead of using the default one provided by Spin, you want to use a Redis which is running on this URL, and then you can use it, and without having to recompile the code or anything, you can just run spin up with the runtime config, and your backing store is replaced automatically. So you don't have to deal with recompiling the code and stuff like that. So that's really good.
So let me start with saying, when Rajat said the capabilities-based model systems, for example, like when you write a serverless app, you want to specifically mention what kind of abilities that it has on the host machine. For example, now this is an example of where it's a simple app which keeps track of the count of times that you have executed it using a key value store. Here, for example, when you look at it, you have to specifically provide it access to a key value store saying default. And when the component is run, if it tries to access any other key value stores, for example, let's say it's called data, that the host component will not allow it. So it allows us to execute code with a bit more of trust factor, and that allows us to also execute some arbitrary code, making sure that our data doesn't go anywhere we don't want it to go. So the simple example is you just import implementation of KV, and then you're able to just, as Rajat said, you're able to open it and access it. So let me just run it using the default implementation. So I've already, I'm just going to build it, and so what, I already have some app running. So once the app is built, you're able to start using your app, for example. So the advantage, and then once you're done developing and now you want to deploy it somewhere, or you want to use a different backing store for whatever reason it is, it might be a compliance reason that you have to have your data stored somewhere else, so you can have your own Redis server somewhere else. And in that case, you just write a Redis config telling it what server to use as the backing store, and all you have to do is just tell it what. And now if you look, I have a Redis server running here, and when I do a get execution count, it runs on Redis. The advantage of this is the developer's code can be oblivious to the fact of backing implementations, and the code is going to behave in a consistent manner. So for example, so this allows us to provide a really smooth developer experience where your local environment and the production environment behave in the same manner, but you don't have to manage any of the operational aspects of it. So that is the biggest advantage of runtime config. Runtime config can also be used for other aspects here. And this is mostly possible due to WebAssembly's hyperportability because of how the host code and the guest code interact using an interface. As long as there's a standard interface, the guest code doesn't care what happens on the host side. So you're free to write your own Redis implementation, or if you want to use MongoDB, you can write any of those host providers and you could have it run. So once you have built your app, now you might be like, what now? Where do I deploy it? Where can I run spin apps? So the answer to that is you can run spin apps everywhere, essentially, where there is Kubernetes. And Fermion, as a company, we also have our own managed platform called Fermion Cloud, which you could deploy your apps to. Or if you want, there is an open source implementation of how to run your own infrastructure with spin on it. So now we come to a question of, so far we have been talking about data. What about compute? So AI is all the hype right now. So it's more like, so we were thinking about, we were able to time share CPUs pretty well to efficiently pack apps. So we were like, can we do that with AI? So with AI today, you need like very expensive GPUs to run your large language models, for example. So the two options that you have are, one is either you rent your own GPU, which is really expensive if you're just doing some small testing. Or the other option is to use the serverless, which, for example, starts up a container which takes like 2 minutes, so there's like a cold start time to the app, and therefore to justify having a cold start, you want to keep it warm for like 15 minutes or so. But if you don't get any requests, you're actually paying for time that you're actually not using the GPU. With WebAssembly, since the cold starts are pretty fast, what we are able to manage to do is the cold start on the GPU becomes in the order of milliseconds, so you're able to use the GPU and release the GPU to use other requests. So we are able to like time slice the GPU much more efficiently here, so that the cost of using a GPU can go down. Spin also has inbuilt support for LLMs, LLM inferencing using custom models like Llama, and even GPT architecture and a few more architectures are supported. This is how it works. And so to demonstrate it, I'm just going to show a small demo of a recommendation service, which uses a bunch of the stuff that Spin provides, like the key value store for caching, the SQLite for storing embeddings, and then Spin's LLM interface to create the embeddings. So this app is just going to be you index a blog, get descriptions of each of the blog posts, and once you have the descriptions, generate embeddings and store them in a database. And when someone else is reading a post, you see what the description of that post is. And based on vector search, you can find similar posts and you're able to recommend it to them. So this is all the features that Spin provides. Although it says Fermion Cloud, this is similar to how it works in Spin. And on Fermion Cloud, we have partnered with Civo to provide us GPU instances. So locally, when you develop, you're able to use your CPUs and deploy it. And when it's deployed, it runs on GPUs without you having to manage any of the dependencies or bring in new libraries or any of that sort due to WebAssembly's hyperportability here. And before the example, I just wanted to give some context on what embeddings and vector search are. Embeddings are nothing but a vector representation of a string. When you generate an embedding, you take a sequence of words and you return back a vector of a fixed size of floating points. And vector similarity search is when you use those, you find similarity scores between two different vectors, and that allows you to identify how similar the two sentences or the bunch of words are, which can be used for finding suggested posts. So this requires two APIs for us to write a Spin app. So the first API would be for us to allow us to, for example, I write a new post. I need to add it to the index so that my app knows, or my index has an idea this post exists, and this might be potentially similar to whatever I'm searching for. So how this works is basically you send a request, and this just strips out this line, the title and description is when you fetch the title and description just for storing it in the database, and all you have to do is run the generate embeddings function, which generates the embeddings for the given description, and then you just use the SQLite with vector queries enabled on it. You're able to store the embeddings on the database here, and then once you're done, you have to update a virtual table. Virtual table is how extensions work in SQLite and SQL in general. And once you're done updating it, so the post has been indexed. So when it comes to you wanting to generate recommendations based on what they're currently reading, you take the description of the post that they're reading now, you create embeddings, and then run a query on the database and find the distance of the top 5 row IDs, which are the closest, and you just return that. And when you, the reason it says 6 when you want only 5 similar posts is because the post that you're running descriptions for is the closest to itself, so you just want to remove it from the list, and then you can just use that as your suggested response. So an example of this running, here it's going to use runtime config again, where it makes it easier for you to develop and deploy it. So for example, and running models locally kind of makes you have to download like large models, or like inferencing takes a long time. I'm going to show an inferencing example as well after this. I just wanted to start with vector embeddings first. So Spin also supports host implementation of executing LLMs using request elsewhere. So when you develop locally, you don't want to run your inferences locally and wait 6 minutes before it gives you like a 1-sentence response. So what you do is, I'm just going to send it somewhere on cloud. I'm going to get a response when I develop locally, and when I deploy it, it's going to just run on the GPUs directly. So the example code that I showed earlier was slightly snipped out for conciseness. For example, here we use the KV to cache responses because you don't want to be generating responses every time. So you want to cache responses for a period of time, because you're not going to publish a blog post every minute. So you're safe. For example, I cached it for 5 minutes here, but you should be safe to cache it whatever your blog publication period is, so that you don't unnecessarily waste compute. So you can use the inbuilt KV store here, and then you use SQLite and LLM as described earlier. So I don't want to bore everyone with indexing it, because it takes about 2 minutes, because it indexes like 160 pages. And so here, currently, one of the limitations of Spin is it does not support vector extension. Spin does not support vector extensions on its local SQLite. So what we are going to do is use runtime config and use an instance from Terso. Terso is a company that does libsql, so they have vector-enabled databases which we use, and so that's going to provide us the vector. And if you see the second one, it says LLM compute. This is what does your inference and embedding requests remotely instead of doing it locally. I've already built the data indexes. I can just show you what I have. So these are all the blog post names I have indexed in here in the database, and then when I do a spin up, and now let's say I'm reading a blog that says that's titled "Pass is not dead." So when I send a request saying that's the current post I'm reading, we are able to like generate the top 5 recommendations based on it, based on what we have trained the index on. So this is the embedding example that we have that does simple embeddings. You could, it's very easy to extend this into other applications. Like for example, instead of just embedding descriptions, if you have a documentation page, you can just embed the entire documentation site, and then you can just get the context and pass it to an LLM, and you can create a documentation chatbot that has the context of what actually the documentation says. And there are other things that you can build too. So this was embeddings. Since we have some more time, I can quickly show a LLM inferencing example too. So this is just basically a sentiment analysis app where we want to provide the LLM as a sentence and ask it, what is the sentiment of it? Do you think it is positive, negative, or neutral? So it's a very simple thing for sentiment analysis. All you need is a prompt, and then you can just perform you just give it as a query to the LLM, and the LLM is going to respond to it. So this is where the cloud plugin for the GPUs is going to be really helpful, because if I run it locally, it's going to take a minute for the Llama 2 model to tell me, oh, that might be positive. I don't want, so what you could do is, since the host component allows easy runtime config changes, so when you develop locally, you can develop it using cloud, and then when you deploy it, actually runs on cloud, and while the rest of your data runs locally. I have again written a runtime config here. I might have broken it.
Demo gods.
I shouldn't be demoing things I didn't plan on demoing. I don't know why it doesn't want to work. Okay, I just didn't build it maybe? Was that it? No. Yeah, I seem to have broken it, so.
If you remove the assets part, then I think it
Which
would
one?
work. If you remove the assets, it's looking for the assets actually. So just remove this component from here.
Yeah.
The UI will be disabled.
Although I don't know what the API is to call it, so.
Okay.
I just built the UI, one of the engineers built it, so. Unfortunately, I cannot show this one. I apologize for not being able to show this one, but it works.
So great for doing
Sure. So, and back here, it just tells us about, and if you want to know what else you could build, there are a bunch of examples people have built. It goes right from CrossFit puzzles to tell me a silly walking joke. There's a bunch of things that people have built, and that's where you can find the examples if you want more, and there are more community-built ones. It's called on SpinUp Hub, where you could look at AI examples there. And these are resources, and if anyone has any questions now.
Yeah, so I have one question here. So you demoed that you are giving a SQLite database. So what is the consistency model that you are actually promising for it?
Currently it's eventually consistent.
Okay, so how, like eventually consistent as in?
Oh, I'm not entirely sure. Do you know?
So I think this is because we are using Terso for this, and they have very good considerations about how they do their application and consistency across their regions. So we rely on them for those kind of capabilities.
So Terso as in Leap SQL Terso?
Yes.
Yes.
Oh, okay.
So
they are
our providers for that.
Oh, okay.
On local, it's going to be consistent.
I mean, of course.
And it also depends on if you use runtime config to use someone else as your SQLite provider, it's their guarantees and not.
Okay.
Because all we are doing is we are allowing your guest code to connect to them based on the SQLite protocol. It depends on the implemented backend provider, what they provide you.
Okay.
So just imagine, there is a lot of compute that is required, right? While training also, there's a lot of compute required. But, I can't promise that there is an 100% uptime when you're training.
So we are not in the part of training models. We are in the part of when you use
inference.
it. We are doing the second part of it. We are not in the training space.
But I just want to know, let's say there's a breakage like what you told in a production. Just imagine there is an API that is breaking inside and I don't know about it. Are there any other services that you have from Fermi Cloud which can help me in debugging these kind of things? Because to me, LLM is complex. And deploying something which is using LLM is also even very complex.
Yeah.
And what is your strategy in terms of debugging something?
So the strategy here, I would say, is we provide a very consistent local and cloud environment, because you can run the same code locally and on the cloud because it's portable and it's a bytecode format. So if you manage, when you do it locally, you have all the tools to debug it in whatever manner you want. And if it works locally, it is guaranteed to work on cloud. That's the biggest advantage in terms of developer experience, is what you do locally just translates the same way to cloud. Yeah.
And you might want to talk about Cloud GPU as well here, which is useful in this regard.
That is just a tool that helps you test faster locally. It just runs on cloud.
Gen AI space.
Okay.
So are there any other things that Fermi Cloud is moving towards?
So we are not providing tools on running AI. We are just giving you a way of running your models in there. We don't know whatever the model does, we exactly translate it back to you.
Okay, because you told testing, I just wanted to figure out, okay.
Oh, when I said testing, when you build something locally and you see it running into some certain edge cases, it's going to run into the same in cloud. We are not in the space of developing AI models or improving stuff with it. We are in the space of providing you compute of where you can run your models and if you have a trained model.
So I have a question. You mentioned about cold starts a couple of times, but I think with the latest updates and snap start as well as proactive initialization, the problem of cold starts is almost solved. So do you still think it is a concern in this use case, and how does WASM picture in and solve that?
Okay. So WASM, I'm not familiar with the cold start there, but for example here, cold start is not the only advantage. It is one of the bigger advantages you are getting. But now the portability option and like with the runtime config stuff that I just showed, the other big advantage that you get is you avoid vendor lock-in, for example, because your guest code does not care, and there are a lot of cases where you want to move from one service to the other, but it requires a rewrite. Those are cases too where WASM shines because you don't need to do a rewrite. Your code doesn't actually depend on the backend implementation. Cold starts, it is fast. Even if you don't compare to it, it being 1 millisecond kind of allows you to just execute your function and shut it right back down instead of keeping stuff warm. So that allows you to pack your applications more densely, which reduces compute costs.
Cool, thanks.
Yeah.